Government from AML Department, second year. So today I'm going to talk about on the topic implementation of HMM or hidden Markov model in Python. So we are gonna before seeing the code, we are just gonna see the overview or the applications where the HMMs have been used. So HMM or hidden Markov model is a statistical model that used hidden state to represent system where the internal conditions are not directly observed. This model takes into account Markov process which depends only on the current state and not the sequence of events that preceded. The HMMs are powerful tool in field requiring prediction and recognition their ability to handle uncertainty in sequential data. The application in sequential data. So HMMs are widely used for modeling sequential data which consist of data points collected or indexed in sequence. This includes application in speech recognition where they help decode spoken words or NLP or natural language processing, assisting in tasks like parts of speech tagging and name entity recognition and biometric information, aiding in gene predictions and protein sequencing also. Their versatility in various domains makes HMM a fundamental component in many AI systems. So where and all the fields which has been HMM is applied is that they want a strong ability to model complex system with hidden variables. So for example in speech recognition they facilitate the transformation of audible signals into texture data. And in finance, the HMM model market trends and stock prices, providing insights for investment strategies. And also in other fields like healthcare and in security and etc. So what are the components or the probability values we are going to be just using in this set? The first is hidden states and observations. So in hidden Markov model, hidden states can represent the internal condition of the system that can't be directly observed. So for example, the weather being a sunny or rainy in this case. So observation on the other hand are visibly output that can recorded or measured such as action taken in response to hidden state. This relationship between hidden states and observation is fundamental in deriving meaningful predictions for the model. Transition and emission probabilities. So transition probability is like defining the likelihood of moving from one hidden state to another in the sequence. These probabilities form the backbone of model's predictive power, dictating how the system evolves over the time. Emission probability indicates the likelihood of producing a specific observation from the hidden state. Together, these probability encapsulate the dynamics of system being modeled. So last, the initial probabilities represent the chance of the system starting in each hidden state before the observation occurs. So these probabilities are crucial in setting the stage for modeling the sequential of data as they determine the starting condition for analysis. Accurate estimation of initial probability enhance the model's ability to predict future observation based on the past. So for example, if you're going to take a sequence of 3 days or three consecutive methods, the initial probability will play the important role in such that if we are calculating properly the initial probabilities, then the upcoming probabilities have higher chance to be better. So as we conclude that in summary, hidden Markov models are powerful statistical tools used across various fields modeling uncertainty in sequential data. Understanding their components, including hidden states, observation, and associate probabilities, is essential for leveraging their full potential. HMM continue to advance various industries by enabling better predictions and insights in complex systems. So now we are gonna see about the in code or Python code for. So first we are gonna import the packages in the Google Colab, and I'm using Google Colab for running my code. So first I will import the NumPy for various tasks like creating arrays and summing up and initialization of zeros. So we'll see that. So first we need to define the transition matrix. As we said, the basic things to calculate the hidden Markov models are transition matrix, emission matrix, initial probability, and observed sequence. So we are gonna define it by using np.array. So the function is used to create uh, 2D arrays of data or ND arrays of data, we can say. So next we are going to initialize the alpha matrix. So this alpha matrix will help us to know that the next sequence of data how we are able to calculating. So we are going to initialize it by len of observed sequence and len of initial probability, and also we are calculating the first alpha value such that we can able to calculate the upcoming alpha values through the next for loop. And next we are going to calculate the probability of the sequence observed sequence by summing up all the alpha values, and also we are printing it. And for finding out what is the sequence, it's going to be rainy or sunny, we are going to use most likely sequence to find out that. So if the alpha value of first one is greater than second one, then it's most likely to be the, we can say that the probability of sunny is greater than rainy. So that we are going to be appending in the array or list sunny. If it's not that, then it's going to be rainy. So at last we are going to print the sequence. So what are all the weather state? So this is the probability which can be able to see when we run this code. So it's 0.024, and the sequence which has been given or found that sunny, 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 and rainy, sunny. So thank you.